All right. Good morning, good afternoon, good evening. I don't think it's evening I don't suppose it's evening somewhere. Good morning to all of you. I am Nick Chase from Mirantis, and I want to welcome you to today's talk about open source hybrid infrastructure. Today we have with us our special presenter, Sean O'Mara. Good morning, Sean, or good afternoon. What time is it for you, Sean?
It is just gone 5 p.m.
Just gone 5 p.m. Okay, so it is evening. It's hard for me to imagine. Anyway, well, thank you so much for joining us here today. You want to quickly introduce yourself?
Sure. Good day, everybody. As Nick said, I'm Sean O'Mara. I'm Global Field CTO for Mirantis, been with the company for a number of years. Focused very much on our strategy and our focus around how we get our message out to the market. As well as I've been designing and consulting around cloud infrastructure for the last 20 odd years. So something I'm very familiar with.
Oh, yes, definitely. All right. So, Sean, you have the con as far as the slides are concerned. So I'm going to ask you to go ahead and advance those slides. And I would like to let's start out a little bit about talking about why are we talking about this? Why is this difficult? What are some of the challenges that we need to kind of overcome here?
Yeah, sure. So, we spend a lot of time with customers, and we've been talking to a lot of customers over the years, and we've tried to distill down the core technology challenges that we're seeing customers dealing with this idea of dealing with a hybrid cloud, dealing with going into the challenges around building cloud native infrastructure. And those challenges boil down to many more than these, but these are the core ones that we're seeing. And the first of those is visibility and control. We talk about hybrid cloud here, and maybe we should have unpacked that to begin with, but we're talking about the world of where we're no longer running our workloads in one single data center or one single place, but the world where those data centers are stretched across public cloud, private cloud. Sometimes they're on-prem, sometimes over multiple public cloud providers. And this creates this enormous sprawl, potentially, of systems that we have to understand. And it's very hard to get visibility of that because, of course, different cloud providers have different systems for doing that. And never mind actually controlling that in a structured way. We'll touch on more of that as we have the conversation today. Related to that, obviously, is operational complexity. The more different systems I have to manage, the more layers of abstraction I have to deal with, the greater the amount of complexity. And now with Kubernetes added into the mix and all the vast array of choice that I can put on top of Kubernetes, never mind run underneath Kubernetes, just operating all of this can become enormously complex. I need a lot of people to help you manage that.
And a lot of different skill sets, I would assume.
And a lot of different skill sets, yeah. The flip side to what I've just said now, which is the multi-world and multi-cloud idea, of course, is customers who then go, well, we're going cloud, we're going to a single provider, we're going to go all in on public cloud provider X. Great, but now you're locked in. You can only use that cloud provider. It makes it very hard because, again, of that complexity, to start to use a second cloud provider to cover things like risk management, disaster mitigation, and all your eggs are in one basket.
Right.
So the big question here is, how do I spread my workloads in a way that's sustainable, that isn't going to create more complexity?
Right. So from a practical standpoint, I mean, how do you deal with these issues? What does this mean on my everyday job?
Well, I mean, your everyday job boils down to, if I've got to deal with 4 different clouds, I've got to go and learn 4 different systems to maintain those clouds. Yes, I can implement a layer of automation around that, but I've also then got to go and maintain that automation. A cloud provider deprecates something in their API, and all of a sudden your automation is no longer working, and you've got to go and dig into that particular provider whilst you potentially have a workload owner screaming at you, never mind customers, screaming at you that their app is down because of your automation. You're just creating this layer of complexity. And you're going to need more and more people with more and more skills so that you can react in a timely manner to these issues.
Aha. Okay. And so you've got categories, I assume, of challenges. I mean,
Yeah.
for like security and so on.
So all of these things fall into different categories. There's one that I really want to touch on before we move on to sort of categorizing and some of those challenges, which is the open source factor, which is very important, I think, for this discussion.
Okay.
This modern world that we're living in, and we'll talk about this a lot more, but this modern world of cloud that we're living in is highly powered by open source. Everybody's using open source in some shape or form. And I want to make sure we come back to that question and touch on that in a little bit more detail as we talk here. So to answer your question, if I just look at some of the practical challenges that people are running into, and break those down, and these again are far from the detailed level, and everything. But
I was going to say, there's plenty more than this.
Yeah, no, there are many more than these, but simple questions to ask is, if I'm going multi-cloud, public cloud, on-prem, how do I deal with things like identity management across all of these providers? How do I enforce policies across all these providers? And of course, the big one, which everyone talks about, is how do I just maintain patching and keep everything up to date across all these providers? So that's it's just a small subset of security challenges. Everyone talks about it a lot, but resource management is more than just, how do I maintain the cost? But it's also about making decisions about the best place to run your applications. It's understanding who has access to resources and who is using those resources. And by resources, I'm talking about compute resources, SaaS services, everything necessary for you to get your applications up and running. And then the big one, and I think we'll talk a lot about that today, is I have an existing investment on premise. I bought hardware. It's being depreciated over this number of years. I go all into cloud. Suddenly, what's going on with that hardware? How do I better leverage my on-premise investment, which I'm stuck with for at least the next 3 to 5 years potentially? And how do I really make that work for me, especially if I need to be on-prem for a number of good reasons? Lifecycle management, and I'll move through this quickly. It's the age-old story. I've got 10 different deployments on 10 different providers, or 4 different deployments on 4 different providers, we'll simplify it. All of them are using some kind of Kubernetes. I'm layering up Istio, I'm layering up Envoy for ingress, or I'm using Calico, or I'm using, you name it, Kubernetes application X that is part and core to the rest of my custom applications. How do I keep all these things consistent and up to date across all these providers? How do I make sure I can make it work every time, that I can have portability of my applications? And then related to that is, how do I ensure that my infrastructure stays up in such a way that my applications aren't showing downtime whilst I'm doing all of this maintenance work? We can go blue-green, but not all applications really react very well, especially stateless applications. Stateful applications to blue-green type deployments.
Right. I mean, so we've talked a lot about this, but what is really special about hybrid versus, say, multi-cloud?
Great question. So I can answer that one. Why a hybrid or versus multi-cloud? Ultimately, to me, they're much the same thing. We're splitting hairs when we split the word hybrid versus multi-cloud. The definition of hybrid is typically two public cloud. It's typically a public cloud provider and an on-prem solution, whereas multi-cloud is two public cloud providers. splitting hairs here because that on-prem could be a cloud system. That's really splitting hairs at the end of the day. But why do we care about hybrid cloud? Well, there are a lot of good reasons for that. The first of those for me is leverage. Every one of these is equally important, but leverage is an important one. And I spoke about that when I talked about risk. If I'm stuck on a single provider, I have no economic leverage over that provider. So if I'm all in on provider X and I want to get a better price, the reality is moving to a different provider, different cloud company, so from AWS to Azure, is actually quite hard. Their systems are not necessarily compatible.
Right.
And what we want to be able to do is avoid lock-in. We want to get away from any sort of lock-in. We want to be able to move our applications with ease. So being able to use hybrid cloud gives us leverage.
Let me kind of touch on that for just a second here, because it seems to me that I'm going to kind of quibble a little bit on the whole hybrid versus multi-cloud thing. I mean, multi-cloud to me means you're using more than one cloud, obviously. Hybrid to me means that your application itself is designed so that a single application uses more than one cloud. It seems to me that in order to get the kind of flexibility where you can move between clouds, you would almost have to have your applications designed in a hybrid way so that they don't care what cloud that they're running on. I mean, am I wrong about that?
Mm-hmm. So it depends on which layer of the stack you were looking at. Ultimately, applications can be made to run. What is an application at the end of the day? From a consumer's perspective, that application could be made up of many hundreds of different parts. And those parts could be made up of hundreds of parts themselves. I mean, you could have a group of stateless API-based services that each perform a specific function. So, function as a service type components. I mean, I'm saying that in inverted commas. But you could also have stateful components that are databases. You could have those FAS components, for want of a better term for now, so those functions running on a cheap public cloud offering where I'm using spot instances to spin them up only when I need them, but my stateless components could be running on a different cloud, stateful components could be running on a different cloud provider where it's cheaper to run those. That would still constitute a hybrid application. It's not necessarily just not like splitting your actual Kubernetes cluster across multiple clouds. There's so many layers to this that where do you draw the line? And I think to a certain extent, every deployment is going to be slightly different because we each are going to approach that architecture in a slightly different way.
Gotcha. So that makes perfect sense. When I talk about, an application, I'm talking about kind of like the whole sort of the holistic view. And so by breaking it out into many of these smaller microservices, that may be running on a single one. So so I guess we are talking about the same thing. Yeah.
Yes, we are. I mean, but that's a great point. A modern application isn't a big monolithic thing that we have to spread, that we need to horizontally or vertically try and scale by just throwing resources at. A modern application is made up of microservices. Now, microservices, when we break it down, could be one container or a clone of that same container 100 times to handle the workload. That's microservices at the end of the day. And microservices isn't that new. I mean, we just happen to be using containers for them now.
Exactly, right. Okay, sorry. So let's get you back at why all of this matters then.
Nice. I can always rabbit hole, you know that. So why all does it matter?
But your rabbit holes are fun, Sean. They're fun and informative.
Well, I'm glad. So the next one for me, and these are all very much related to each other, and we've talked about this to a certain extent, but efficiency is very important. And when I'm talking about efficiency here, I'm using it in the same sort of terminologies I would use location. Ultimately, it's about using the resources where I need them that are best suited for the job, which also can directly relate itself to location, which is, we talk edge as an example. I want to move that workload closer to the user and only run it when that user needs it. And so those two come together by moving workload potentially, so making it more bring the proximity to the user, as well as only use the resources I need, where I need them, and where they make sense at the time. Now, it's a bit of a dream, but we are going to be able to get there very, very, in the near future. I don't think it's 20 years out, it's next year, year after, where we really are going to be able to move our workloads around this way. It's definitely something that's coming.
It's very, very close.
It's very, very close. I mean, we're starting to even see industry definitions of APIs to try and achieve this. So
right.
It's very close. And that's going to be a big game changer to the way we consume infrastructure. We spoke about risk mitigation, spreading the risk, allowing us to leverage providers, also making sure that we're not bound into a single provider, that if there's an economic problem with that provider, that they fail as a business, or if they have a technical failure, or they come under legal problems, that you're not stuck there and you don't end up with downtime. Then, and the biggest and the last one, which I want to talk about here is the why, is again related to location. So a lot of these have a close relationship, but regulation. In many cases, data is heavily regulated. I'm in Europe. We've got, I happen to be in Germany. We have to deal with GDPR here. My personal data has to be stored within the EU. And there are all sorts of rules to protect my personal data, which anybody who's collecting that data, whether it's for shopping, health insurance, and the list goes on, has to comply to those rules or risk very, very large fines. There are other jurisdictional needs that we have to take into account, regulations about who can have access to our data, government information. So all of these things also start to make hybrid cloud important, and being able to pick my resources again where I need them, and being able to use resources where it makes sense for me.
Right. Okay. So then how does all this tie into actually using cloud and open source and all of that? So let's kind of move down one layer.
Yeah, so let's go down that layer and let's talk a little bit about open source. This is obviously a bit of a pet topic of mine, and I know this is one that's important to you as well.
Definitely.
Yeah. So I threw up just a couple of stats here, and some of these could be a little deliberately so. They're a little bit, me trying to poke fun at it, but it's also quite serious. There was an interesting, and I've lost the reference to where I got that number from, sorry, but more than 78% of businesses are using open source software. Now, when I say they're using open source software, many of them aren't even aware that they're using open source software. They're potentially buying closed source software or commercial software that has open source components embedded into it, or their developers are using it without even having told anybody. So open source is absolutely everywhere. Now, the great thing about open source is it enables us to move faster. Developers and operators can build new services really, really fast. They don't have to go and reinvent the wheel every time. They can leverage everything from libraries to fully functional applications that will provide baseline services to databases. I mean, the list can go on and on, but ultimately it allows for speed. But what we have to realize about open source is that it is inherently selfish. This is where I'm starting to maybe stir the pot a little bit. What I mean by this is open source contributors really are only trying to scratch their own itch. They're trying to fix the problem that they have and build on what other people have done. Overall, we all benefit, but we have to realize that one of the challenges around this is we now have an application that isn't being, or a library or a system that isn't being maintained by one cohesive group sometimes. It's been contributed to by a very broad community of people, and it's probably leveraging other open source projects to achieve its goals. And those challenges are what we need to understand in any system that we're thinking about in the modern world. Now, I'm not trying to say that we should run around screaming with our hair on fire here that the world's going to end or the sky's going to fall, to use an asterisk reference.
That is a very interesting image, knowing you, Sean. I'm sorry. Go ahead.
But what I am saying is we have to be aware of these challenges, and we have to take into account that open source has to be treated carefully. We have to know what we're using. We also have to make sure that we can maintain it, which comes back to that earlier conversation we had around dealing with the resourcing of people and operations management of this entire world. We've got to deal with security, we've got to support it, we've got to have skills for it. And do you as a organization really want to become infrastructure experts if you're consuming an infrastructure project, or do you want those smart people to be focused on building value for your applications? Just a question to put out there.
Right, obviously. Okay, so now obviously we've been building towards an idea at this point. We've laid the groundwork. So what are we trying to say?
So let's get to the point, yeah.
Right.
We have a vision for the future. As Mirantis, we have a very strong vision for the future of how we would like to see all of this tied together. This is all about providing a way for everybody to consume this open source hybrid multi-cloud world, allow them to have compute absolutely everywhere. So run your workloads wherever you need them, from the core data center to the edge to on-prem to consuming public cloud. The world is going to be using a hybrid of systems in the future. We also strongly believe that workloads need to be portable. Ultimately, anytime we lock ourselves in with a workload and we don't have that portability, we're creating that risk that we spoke about. Our world is moving towards, and the expectation of the consumer is that we're moving towards faster and faster speeds and better overall resource utilization across the world. So proximity is going to be a key factor of this, and we want to enable proximity to be an easy thing for developers to consume.
Right.
And then the core of that vision, and the reason I spoke about open source as much as I did, is the ecosystem must be open. We must be able to contribute to an open ecosystem, and I think open source is very much the future of that. But we want to enable people to access and safely consume cloud services for all stakeholders in the business.
So there is a lot to kind of unpack there. So let's kind of start, with this idea of portability and compute everywhere, and why does this matter, and how do we do it?
Yeah, so I'm probably going to repeat myself a little bit here, but the core of that is we want to be able to compute closer and more appropriately to where the consumer is. And the technologies we're talking here that are enabling this to a certain extent are 5G, guaranteed throughput, guaranteed connectivity, which 5G offers, plus the whole drive towards the edge, being able to put compute closer to the user. And one of the important things here is have that compute function follow a mobile user around. We are more mobile than ever before. Now, yes, the last 2 years has changed that, but I strongly believe we're going to move back to being mobile again. I very much hope so. What that drives is this idea of just-in-time or on-demand computing. I am in my car. I leave my home in the morning to take my son to school. I have my mobile device that's potentially showing me real-time traffic mapping data. Why should that compute be running in my house when the nearest compute point is at the school, which is 15 kilometers away? And that's probably a terrible example, but the idea that we're moving around just in our cities and allow that compute to run where we are, rather than creating latency back to a central point. This was one when I was thinking about this, and the conversations I've been having more recently, it's becoming interesting to see how green tech is also starting to influence our choices about compute.
Yeah, a lot of people are starting to really notice this and talk about this. A statistic that came up yesterday, don't quote me on this, but it was something like 80% of Ireland's power consumption is going to be data centers in the near future, something like that. It was a ridiculous number.
Sounds likely, but yeah, I mean, it's insane. There are data centers popping up everywhere. Green people are becoming much more aware of the resources they're consuming outside of the traditional electricity and water into your homes. People are starting to become aware of where their data is being processed. Is that using renewable energy? Is it using cooling that's sustainable? Am I pushing my data over 10,000 kilometers of fiber optic cable when it could quite happily have been done locally for half the price? Why? Why are we doing this? And people are starting to become a lot more aware of that. There's also this idea that we can shut down compute when we don't need it anymore and conserve resources, distribute that load better. And of course, that leads in very much into the discussion around commercials. People will vote with their feet, obviously, to what's most affordable. It's just typical. But as people become more aware, the whole compute everywhere becomes very much a commercial discussion, as well as, of course, the very obvious commercial discussion of if I can run my workload in provider A's data center for half the price of provider B, I'm going to run it in provider A. It's just natural.
Right. It would be irresponsible not to, really.
Yes. I mean, commercially irresponsible, and ultimately we're all beholden to somebody in that regard.
True.
I also wanted to say I threw the containers and Kubernetes bar across the bottom of this for a very good reason. Containers, the container ecosystem, Kubernetes is the orchestration mechanism, really is one of the core enablers for us to achieve a lot of these capabilities moving into the future. And I strongly believe that. Yes, work needs to be done to bring them to that point, and it is going on, and it's getting better every day. But just wanted to say that this is one of those core technologies that's going to help us drive this vision.
So one of the advantages of all of this, and we've talked a lot about proximity in this. So let's talk about why that matters.
Yeah.
Who cares? Really? Seriously.
A lot of people. I do.
Yeah. I know. I'm not saying it's a bad thing. I'm saying why do we care? Why do we care about this? For years, for many years, we've had compute running in, I'm in Ohio. For many years I've been running a lot of stuff out of Virginia. It works just fine. Why does proximity matter?
Perception is primarily one of the biggest things, and I want to give that as an example. I have a young son who loves playing games, and he plays a online game with a lot of his friends, and they have thrown up this idea that I keep hearing them calling out, "Oh, the system glitched. Oh, I died. What's going on? Oh, well, the server that they're running the game on happens to be sitting somewhere outside of New York."
No.
And yeah, they run into a latency problem. Every now and again, they run into a latency problem. And in the game, they're having a fight or they're trying to capture something and it glitched just for a couple of milliseconds.
Yeah.
And suddenly they lost. So
it makes a difference.
Now we're talking about a game for a bunch of preteens. Most people say, who cares? Well, let's take that up into a medical system. As we move into the future where we're all online and we're all using online doctors because we can't get to our doctors, now suddenly a glitch in the system could mean a misdiagnosis. Imagine remote operating. Things like that start to get interesting. Automated cars.
Oh, yeah,
the system causes an accident.
And let me kind of make this more visceral. Right now, you and I, Sean, are about 30 seconds ahead of the audience.
Mm-hmm.
If I said right now, in fact, I'm going to do this. Okay, I would like everybody to I would like everybody right now, when you hear this, just say hi in the question pane. Okay, just ask a question that just says hi. Now I'm going to say that right now, and when the first one comes in and I see it, I'm going to tell you, and that's going to tell you how long the latency is and how impossible it would be for us to carry on, say, a live conversation. But you were talking about um, driving cars.
Sure. So imagine an automated car that took 30 seconds to respond to a child crossing the road in front of it.
Yeah, I mean that's not a pretty sight.
So that all boils down to latency. We all think we can solve that challenge.
Here we go. The first hi just came in just now.
Oh, that's interesting. So that was
Just
about 30 seconds.
Yeah, so it's a long time. So for
Yeah.
those of you who are listening live, you've been waiting for that to come up. It just came up just now. Okay, sorry. Go ahead, Sean.
So again, that comes back to the conversation, and I think all of these things, but also resources. If I'm using an edge compute system, I want those resources to be distributed more evenly so that they're spread out. So I don't have to go and have a lot of resources sitting idle most of the time. That I'm
Right.
utilizing my resources in the best way possible, then I can build and provide those resources where there is higher density and not do them where there's lower density and not have to deal with long, expensive transmission lines and the like.
Mm-hmm.
That obviously is directly linked to location again. And I'll come back to the conversation about scarcity and green tech and the investment thereof.
And there's another issue on scarcity too right now with chips starting to be scarce.
Mm-hmm.
You gotta put your compute where you can find it.
Yep. I mean, we had that conversation a couple of weeks ago in the Cloud Native and Coffee, where we were talking about how long it takes for service to be delivered and chips to be delivered in this modern world.
Mm-hmm.
We've got to deal with that. We've got to understand how we cope with that and make sure that we're using all the resources we have available to us in the best way possible.
That's right.
So,
Okay. Yes. So moving right along. I rabbit holed you again.
yeah, that's easy to do. The last thing I really want to just talk about is the whys of open versus closed. And this may be super obvious to a lot of people. And I won't spend a lot of time here, but ultimately, open versus closed ecosystems are around encouraging competition. Some people say closed ecosystems are better for competition. I don't believe that. I think an open ecosystem truly does encourage competition, and it forces people to be more creative in ways that they provide services. They definitely prevent lock-in, open systems, by ensuring that freedom of choice. I mean, obviously, the opposite to that is it reduces consumers' choice by having a closed ecosystem. It creates, I hate to say it, but it creates a form of monopoly in its own way. Open ecosystems also enable portability because we can then leverage that open source. We can leverage all of these different systems. And we also reduce, and you just spoke about it, our impact on the global supply chain. So,
Right. Okay. So, all right. So how do we go ahead and make this happen? Let's talk about that.
yeah, so straight up, we put the makings of the solution down. And the idea that we are coming up with is this idea of building a multi-cloud thin layer across all of these provider choices. And then you run your application workloads and everything else on top of that. So what we're building and what we've built and what we're taking to market, and we're putting this under the Mirantis Flow banner at the moment, is a way for you to Forget about that entire stack of systems underneath that. Let us look after all of that. Manage across this multi-cloud, create a consistent solution across all of these different providers. And I mean, this slide is deliberately simple for that point is we're creating a thin layer that is primarily Kubernetes based underneath this. So what are we actually doing and what is our offering? So our offering is Mirantis Flow. We're offering the cloud native data center orchestrated through Mirantis Container Cloud.
You want to talk real quick about what a cloud native data center is?
We can do that. Ultimately, yes. A cloud native data center is a full stack data center where that data center is no longer bound to a physical building necessarily.
Okay, and I know you'll get more into it later, so I just wanted to kind of set that level set before you go forward.
Yeah, it's a very good point. It's saying that the data center is no longer to be seen as a single provider or a single building, but the idea of that we can run our microservices applications, our cloud native applications, whether they're Kubernetes or VMs, where we need them. So whether they're containers or VMs, and what we're offering to achieve this is all based on a Kubernetes platform. So self-service on-demand, complete Kubernetes as a service. So the idea is here again, we create that thin layer using Kubernetes, allow you to deploy a consistent, cohesive Kubernetes platform across any provider, whether it's bare metal in your data center, a private cloud, or a public cloud service. We're including built-in monitoring, logging, and alerting capabilities, provide that visibility, provide that single pane of glass. Part of our offering, we're including deployment and onboarding to make it easy so you can get started. And really importantly, we handle the operations. We do 24/7 proactive operations and support so that you can either just enjoy your life and focus on putting applications down and not have to deal with the complexity. We also own that open source. So just to put this in perspective of what we are providing holistically, and this is across all of those providers that I showed earlier, and I'll show another diagram in a second.
And remember, everyone, we will handle this for you, so don't let your eyes bleed.
Yeah, I know this is quite a complex diagram, but ultimately everything in blue, I think it's blue, is
blue, yes.
Handled by Mirantis. And what's important is we're providing that Kubernetes layer, the virtualization and containerization layer across all of these infrastructure choices. So what are our key guarantees that we're offering as part of this? Firstly, as I mentioned, the rapid deployment. We'll deploy within 48 hours of the hardware being verified or onto the cloud platform of your choice. We will reduce the overhead for operating that infrastructure. So we'll take over the overhead through a combination of fully automated and integrated lifecycle management, combined with our OpsCare offering for visibility, and with OpsCare Plus, we can even do that full management for you. We are providing and offering, as part of the Flow offering, a kickstart to help you with that process of understanding how to onboard your workloads or migrate those workloads. So many people are running workloads on legacy systems. They have a plan that they need to enact to get them into public cloud. They're probably into the cloud offering. They're probably still trying to get the cloud offering just to work for them. And now they've got to deal with that complex layer of migrating applications. We'll help you that and put the guidelines in place to make that happen. And what's important to us as part of this offering, because we're offering the full Mirantis stack, we can also offer you virtual machines in your data center and containers on the same infrastructure, offering you a complete solution right out from inside your data center out into the public cloud. How are we doing this? So the core of the offering is based around Mirantis Container Cloud. Container Cloud allows us to cover all of these different providers. So all of these cloud providers, so we've got Azure, AWS, Equinix Metal, VMware, OpenStack, and then bare metal in your data center, we can orchestrate your existing bare metal infrastructure, allowing you to continue to use that infrastructure, and then we can layer that up either with OpenStack or Kubernetes on it as bare metal. Utilizing Mirantis Kubernetes engine, right now we can cover a lot of different use cases. When with K0s coming into Container Cloud shortly, we can start to also cover more of the edge use cases and more interesting use cases. Combined with Lens for the overall visibility of the entire solution. Lens is your single entry point to all of this. Stacklight provides for the logging, monitoring, and alerting. Also provides for the connections for the OpsCare solutions so that we have all of that information and we can respond appropriately and be proactive about the management. And then we've got some add-ons like Mirantis Secure Registry, which allows you to create a very strong secure software supply chain where you can ensure that only workloads you've approved and that have been validated are running in your environment.
Okay.
How are we operating all of this? Sorry, Nick, you want to say something?
No. I was just going to say, okay, so how are we going to do this? Go ahead.
All right. So how are we operating all of this? We're delivering it through two choices. We've got our OpsCare and our OpsCare Plus support offerings. Both include support for scaling out your environment, the design and the deployment of the initial environment, the lifecycle management, so everything you need to keep that environment up and alive, patching, upgrades, all included as part of the software and the support solution. And then the operations component, we offer two flavors where you can operate your environment through the automated tools, but will act as your first line, handling the alerts and the escalations, or we can even just operate that environment entirely for you, and all you need to do is worry about your workload. It's a proactive support model. It includes the logging and monitoring. We're offering it, as I said, 24/7. We offer different SLA options. And there's a deployment validation agreement for your environment that we will help get everything up and running within 48 hours.
48 hours. So let's just kind of, yeah. So now normally people are used to this taking how long?
Weeks to months.
That's why I want to make sure we're talking about actually 48 hours. It will be up and running. And how long until the first workload is on there?
So you'll be able to put that first workload within 48 hours. Our promise was to start working with you to get your first workloads on there by the end of that week.
That is fast.
Yeah.
That is very fast.
And we're able to achieve this through a combination of our software offerings. So what Container Cloud offers us being the core of Container Cloud, it goes on in little or no time. As soon as that hardware is available to us and we've done the basic setup of that environment, Container Cloud goes in and everything else comes from there. Everything else stems from there through a completely self-service for the Kubernetes clusters. So once the infrastructure is in place and has been validated, all you need to do to get a Kubernetes cluster is pick your provider, click the button, and within minutes, you've got Kubernetes clusters on all those providers. And you've got that, and I'll go back to this diagram, you've got that central point, that Container Cloud, where you have a vision and a view of your entire, visibility and a view of your entire environment, where all your resources are, how big your clusters are, and you can scale and manage them from there.
And we're talking about clusters on any of these providers.
Correct.
So not just like pick one.
No, pick any of them or all of them.
Yeah. So you can have something on AWS and something on Equinix Metal and, still keep your VMware and all of that.
Yep. And have a consistent setup across all of them. So at the end of the day, when I have a cluster, when I build a cluster on top of Equinix Metal and consume their bare metal solution, and I have another cluster running on top of AWS and EC2, from an application point of view, those clusters are the same. They have the same internal mechanisms, the same workings, the same SSO. all the rules are the same so that I can move my application around and just take advantage of the resources underneath them, or use resources that are more proximal to where I'm trying to achieve.
And so I don't need to say have a certification in the AWS API.
Correct.
Okay. Okay. So uh let's see. So I think is there anything else that you wanted to talk about before we kind of conclude and go to questions?
No, I just think that the one thing I would say is this is the full stack view of the way we're presenting this is completely unique. There are other players who are saying that they can do it. Um, Ultimately, we're independent of any of the providers. We do it for the full stack. So we're looking after the full life cycle of all of these clusters, not bits and pieces of the life cycle. So not just
Right.
Kubernetes. We say we look after Kubernetes, we look after the operating system, we look after the virtual infrastructure that is underneath that, or the physical infrastructure that's underneath that. So all the networking, all the load balancing, everything else that is related to the solution all happens here through one set of interfaces, one point of monitoring, and one set of standards.
It sounds reassuringly straightforward. As someone who has been struggling with all of this stuff for many years. So, okay. All right. So are you ready for us to start talking about questions?
Yes, let's shoot some questions out there.
All right, wonderful. So the first and easiest question to answer is when would the questions be answered, which is now, or 30 seconds from now, as the case may be. So let's see here. We have, the first question that we got actually was, how do we set up a meeting? So if you go to the Mirantis website, there's a contact us button. That's going to be the simplest thing, or I think Lisa will get your information and we can get you going. Are you using Prometheus and Grafana for monitoring and logging?
So Stacklight, it contains Prometheus and Grafana. It also contains, it's a full elk stack. So we use Prometheus primarily for events and for capacity information. And then the elk stack is used for logging and log management and alerting around the logs and proper reporting around the logs. So Stacklight is made up, once again, as everything we do, of open source components, but it's fully integrated and provides that great user experience. So you've got Prometheus, you've got Grafana, and Kibana for the logging components.
Okay, excellent. Does it have image scanning also?
So as part of the secure registry, we have the ability to do image scanning, binary image scanning, as well as a full promotion process around that image scanning. So we partner with Synopsys. We do deep binary scanning. We also have the ability for you to plug in your own scanner of choice. So should you wish to use a third-party scanner of some sort, you can do that. And then you can have strict promotion rules around that will then allow, as part of that scanning, whether images are promoted and made available or not, or fail the pipeline potentially. And we obviously offer not just for we offer that not just for containers but for Helm charts as well.
Okay, cool. Can you put the architecture diagram back up so we can kind of see where that is in the
Try. There we go. So this is secure registry. It runs on top of this or to the side
there
until
we go.
container.
Okay, excellent.
And
So
look
yeah,
out for our road. I'm going to punt our roadmap session coming up next week a little bit. Look out for that. We'll be talking about some of the cool things that are coming down the road for that.
okay, excellent. And actually, I think I'm giving a talk on that at DevOps World this afternoon. So there you
Cool.
go. All right. So we have another question. What is K0s for?
Great question.
That is a good question.
So K0s is a lightweight single binary distribution of Kubernetes. Again, fitting into the Mirantis view of a full stack of Kubernetes. K0s is designed to make it easy to run a very, very small, lightweight Kubernetes with none of the extras that you need to actually, you have to add all that, ingress, everything else on top of that, as K0s is today. But because it's a single binary, it's very, very simple to maintain and manage on small footprints. And that's what K0s is all about. Watch this space. We've got some cool stuff coming up with K0s in the future. It's complementary to what we're doing with Kubernetes Engine. Kubernetes Engine is much more a complete solution as it includes the ingress, the networking, the identity management. K0s is just a very simple Kubernetes only offering. More to come in that space.
Okay. And all right. So if you have any other questions, now is a good time to drop them in. We are getting towards the end. Also, so K0s is sort of is great for IoT and edge and things like that, I would think.
Yeah.
All right. Awesome. Okay. So I think the only other question that we have has to do with DevOps world and some issues there. But Lisa is our producer Lisa will take your information and we'll get you straightened out there. So we have, like I said, I think we are coming towards the end. We have like a 30, like I said, we have like a 30-second gap. So I think we are done. If we have no other questions, Sean, if you have nothing else that you want to add.
Just, I'll put up that last slide again. I mean, we're very excited by what this can do.
Extremely excited.
We've had a lot of great feedback already. We'd love to hear from you if you have ideas.
You know what? I would like to wax poetic on this for just a minute, if I may. If I may, one of the things that I'm really excited about Mirantis Flow is the ability to is the whole data center as a service part. The ability to sort of create and manage and destroy clusters the way that we normally would create and manage and destroy pods. So if you need a cluster over here, you go ahead and you pop it up, and you can do it programmatically using the Mirantis Container Cloud API, and it doesn't matter which what kind of cluster it's on. I mean, there are some technical things that you need to do, but you don't need to know every single cloud's API. I'm so excited about the idea of being able to sort of programmatically orchestrate these clusters. I kind of I have this image in my head of sort of the sorcerer's apprentice with these clusters and things, although of course I do not want to be drowned in clusters, but you get the point. I'm very excited about it. I know that I sound kind of bouncy, way too bouncy for this time of the morning, but I am really excited about it, and I encourage everyone to check it out because it is very exciting, and this is the future of where we are going.
Yeah.
So and when I say we, I don't just mean Mirantis. I mean the industry has to go in this direction. There's really no other alternative. All right. Well, we do not have any other questions that have come in. So it is time for us to close. So I am again, Nick Chase from Mirantis, but I am the least important part of this. So I am going to say thank you so much to Sean O'Mara, our presenter today, and also to our super producer, Lisa Wallace, who has been in the background handling things. Uh, and we are so glad to the most important people, which is all of you who are out there watching this. We know that you are busy and you have a ton of things, and we appreciate you spending the time with us. And we would love to see you next time. Thank you so much.